So in this video, we're going to talk about nonlinear systems of equations. So nonlinear systems have at least one equation that is not linear. We're not exactly creative when we name things in math. Okay, so just to show you like what we're talking about here. So like here's an example of a system. So this would be a linear equation because it's just x and y, but this one is not linear. This would actually be like a parabola. So you don't have to necessarily know like what shape the graph is, but I'm just stating like this is not linear. And then in this set of equations here, neither equation is linear. So it's got to either, so linear means, it's the equation of a line. So if it's not the equation of a line, then it's a nonlinear system. Now to solve nonlinear systems, this is a little bit of an art form. So you can use substitution, elimination, or a combination of the techniques. So these are the ways that you solve just regular linear systems, right? These two techniques. There's a best choice when you're working with nonlinear systems. Now, the one thing that you want to watch out for when you're doing this is you want to watch out for erroneous solutions. So you always have to double check all of your solutions because it's possible with these types of systems that you'll find a solution that doesn't actually work and you won't know until you plug it back in. Okay, so let's just jump into a bunch of different types of equations and I'll just walk you through some of the solving strategies. Okay, so let's say that I have a nonlinear equation and then a linear equation. So this here is linear. Again, it doesn't have anything squared or absolute value or anything like that. So when you have at least one linear equation, then you're probably going to want to use substitution. So in this case, I would want to solve. So let's solve for x here. So if I solve for x, what does this become? This just becomes x equals y minus 2, right? And so with substitution in this case, then I can easily substitute this into my x here. That's one way that you can go with this. And so notice what's going to happen if I do that. So I want to point out just like how you can kind of play with this a little bit. So if I make that substitution, so then my x will become this y minus 2, but I need to square all of that. So look at this. This requires me to FOIL this out, okay? So this is going to be a little bit of work. Now, if you don't like that, a lot of times you can play around with these. So if I just want to show you an alternative way to do this. So I had this way to substitute, but I could go another way. I could actually solve for y. So if I solve for y, so I could add y to the other side. So let's see, if I do that, I'd have x equals y minus 2, and then I could add the 2 to the other side. So I get y equals x plus 2. And you could tell that also, like I could have just solved for y here. But anyways, so I bring that up because, if I make this substitution, so just look at how that's different. So then this would become, so I'll do these like side by side. This would become x squared plus x plus 2 equals 8. So I wanted to point this out because you might approach equations like this and it might be going one way and you may have accidentally, like without even realizing it, made the equation really hard. And sometimes you can just change slightly how you're solving it and make it easier. So in this case, I think this is the harder side because I'd have to FOIL this out. So this is y squared minus 4y plus 4 plus y equals 8. And then let's see, this becomes y squared minus 3y plus 4 equals 8. And then I can subtract off the 8. So I have y squared minus 3y minus 4 equals 0. And so notice now I can factor this. So since this is squared, remember you need this to be equal to 0. And so then this would factor as y minus 4 and y plus 1 equals 0. And so I could finish solving. Now, before I finish this, I just want to contrast that to how does that compare to this side where I had everything in terms of x's. Well, now I have x squared plus x plus 2 equals 8. So I just need to subtract the 8. So I have x squared plus x minus 6 equals 0. So I think that this side was easier, right? So technically x was the easier letter to solve for, or variable to solve for. But if I just did a little bit of extra work, I think that like getting my system in these terms is just a little bit better. Okay. And then from here, you can also factor. So this would factor as x plus 3 and x minus 2 equals 0. Now, you're probably noticing now, oh, wait, but I'm going to have different values. And that's true. So this should work out no matter what. What I want to do is I just want to contrast how these two solutions look. So let me just get rid of this side. Okay, so let's finish solving this situation here. So my two solutions in this case would be y equals 4 and y equals -1 from how this is factored, right? Okay, so then how would you finish solving this? Well, you can just go ahead and plug these back in for y. But I want to point out that you have to be a little careful with this. So if I plug in my y into this equation versus the first equation, that's actually two different solving strategies. So let's appreciate this. So let's say that I plug this y back into just the linear equation. So this becomes x minus 4 equals -2, and then I can just finish solving for x. So I add the 4 to each side, so I get x equals 2. Okay, so that was me plugging this into the second equation. What if I plugged the 4 into the first equation? So if I plug the 4 into the first equation, I'd have x squared plus 4 equals 8. So then I could subtract off the 4 to get x squared equals 4. And then when I use the square root property, so this would actually give me x equals plus or minus 2. So notice how this equation gave me one solution, this equation gave me two solutions for x. And this kind of highlights like why nonlinear systems are kind of a weird thing to work with. So in this particular instance, since I know that there's no way I could have gotten -2 in the other equation, I know that I can discard -2. So it's going to be just +2. So that's because, so just to repeat that one more time. So that's because like if I can't get the same set of solutions in both equations, then you've just got to go for the one that they share, okay? So one solution then is 2, 4. So my x was 2 and my y was 4. And then let's do this one more time. So let's plug that -1 into just the linear equation, because that will give us just the one solution, right? So this will become x minus -1 equals -2. So that's really x plus 1 equals -2. So I have x equals -3. So my other solution then will be -3, -1. Okay, and I just want to remind you now of like, remember when we were going the two different ways to solve this system? So if I come back to that, here was the original work. So here were my two possible x's. This came out to x equals -3 or x equals +2. So those are actually the like pairs that we found in this case. So these would be the only pairs. And so so in this case, so I can just skip over the check and leave the check to you to say that I know that these two solutions are right. But you could see how, you might run into extra solutions. And so it's always a good idea to just double check them. Okay, so let's keep going. And now let's look at an equation that has just two nonlinear equations. So these are both circles actually. So in this case, when everything is squared like this, it's probably easiest to use elimination. So what I can do is I can transform this equation, so I can multiply the whole thing times -1. So I have x squared plus y squared equals 25, and now this will become -x squared minus 2y squared equals -9. And so then I'm using elimination, so I just add straight down, so this becomes -y squared equals 16. Okay, and so now I can finish solving for y. So to do that, I'll first take y squared equals -16. And then when I take the square root, so remember the square root property says that you need to have plus or minus in front. So here's the structure of my solution. And so this will become plus or minus 4i. Okay, and so now I have to, these are two solutions, so I'm going to use each one in either one of these equations to try to figure out what my x is. So let me plug this into the first equation just because it looks like it's a little easier. So I'm going to have x squared plus, let's start with positive 4i equals 25. Okay, so this becomes x squared plus, so remember that 4i was equivalent to the square root of negative 16. And so if I'm squaring all of that, this becomes negative 16 equals 25. Okay, and so now, and by the way, if you weren't sure about that, so if you just want to see the math one more time, so 4i, so that's 4 squared and I squared. So that's 16 times negative 1, because I squared is always equal to negative 1. So that's another way that you can remember that, by the way. Okay, so now let me just clear some space. And let's do x squared equals now 25 plus 16. So that's x squared equals 41. So now when I use the square root property, this is going to be x equals plus or minus the square root of 41. So that was the case for when I had positive 4i. Now, just notice if I were to take the negative of that, so if I start this over again, and if I just put a negative in front of this 4i, so negative 4i squared still equals negative 16. So if you want to see the work for that, let me just clear a little space. Okay, so I've got negative 4i. So you can think of this as negative 1 squared, 4 squared, and I squared. So the negative 1 squared is positive, and then the 4 squared is 16, and then the I squared is still negative 1. So this gets us, so I put this negative in front here, it gets me the exact same situation. So I get actually the exact same solutions. So there are 4 solutions in this case. So do you see what all 4 solutions are? So let me clear a little space. Okay, so those 4 solutions then are positive square root of 41, 4i, and negative square root of 41 and 4i. And then positive square root of 41 and negative 4i. And then let me just erase this. And then the last solution would be negative square root of 41 and 4i, or in negative 4i, sorry. And so those are my 4 solutions in this case. And so if you were to go back and check them, you would find that they'd work in all 4. So there's no extraneous solutions in this case. And so just for the sake of time, I'm going to keep going. Okay, so moving on to this next example. So in this case, so just appreciate kind of what this looks like. I've got x squared, xy, and y squared. So ideally where we'd want to start is elimination, and we can pretty easily at least eliminate. It looks like if I just combine these equations as is, so notice what's going to happen. The xy's will drop out and the y squareds will drop out. So sometimes it happens and sometimes it doesn't. So, you know, just ideally you can eliminate several things out. So if I go ahead and I combine these, I get 3x squared equals 15. And so then I can go ahead and solve this. So I have x squared then, if I divide both sides by 3, this will be x squared equals 5. So I get x equals plus or minus the square root of 5. Okay, cool. And so now we have the task of trying to solve for y. So I'm going to plug this now into either one of these equations. I'm going to plug it into the first equation just because it looks easier. Okay, so I'm going to have the square root of 5 squared minus, let's call this y times the square root of 5 just so I don't get confused, and then plus y squared equals 5. So here's the equation that I'm left with that I want to solve. Now the square root of 5 squared is just going to be 5. And so then let's see. Oops, and this was square root of 5. Oh my god, sorry, having trouble writing here. Okay, equals 5. Okay, so now when I go to solve this, so let's see. I can subtract off the 5, so I have negative y square root of 5 plus y squared equals 0. Okay, now just be careful when you're solving this notice that on the left side, we can actually factor. So what can I factor out of the left side? I can factor this. I can rewrite this as y squared minus y square root of 5. Maybe that helps you see it a little bit better. So I can factor a y out of this. And you actually do want to use factoring in this case because you don't want to miss any solutions. So if I factor out the y, I have y times y minus square root of 5 equals 0. And now from this factored form, I can see the two solutions for y. I'm going to have that y equals the square root of 5 or y equals 0. Those would be my two solutions. Cool. Okay, so now that was the case for positive square root of 5. So let me just note those solutions. So I have square root of 5 and square root of 5, and then I have square root of 5 and 0. Okay, so if I repeat this now for the negative square root of 5, so that will change some things in this equation. So let me clear a little space. And okay, so let's plug in the negative square root of 5. So this I get negative square root of 5 squared. So now this will become plus y times the square root of 5, right? So this was a minus xy. So that negative is going to turn it into a plus. So this will become plus that, and then plus y squared equals 0. Okay, so now if I work through this, let's see, this becomes, oops, and this equals 5, not 0. Oh my God. Okay. 5 plus y square root of 5 plus y squared equals 5. So once again, I can subtract off the 5's. So I have y squared plus y times the square root of 5 equals 0. And I can do that same trick. And so in this case, now what I get is y equals 0 and y equals negative square root of 5. So the two solutions in this case were negative square root of 5 and negative square root of 5, and then negative square root of 5 and 0. So those are the four solutions in this case. So you can double check them in the other equation. So again, I know that they're going to work in this case, so I'm going to omit that and leave that to you. We don't have to worry about it in this case. Okay, so for this system, so I think what makes this one a little nerve-wracking is, so I've got x squared plus y squared equals 9, and then I've got this negative absolute value of x plus y equals 0. So this is what's a little nerve-wracking. So I'm going to tell you a little hint that really helps with absolute value problems. So the absolute value of x squared is equivalent to just x squared. So knowing that will make this problem a lot easier, because then I can just solve this particular problem for the absolute value of x, so I can just bring it over to the other side. And then I can use substitution. So I can substitute this now into here, leveraging the fact that I know absolute value of x squared just equals x squared. So I can make this substitution. So this is a really handy fact to know. Okay, so if I make that substitution, then what I'm left with is y squared plus y squared equals 9, which means that 2y squared equals 9. So if I divide both sides by 2, that means y squared equals 9 over 2. And then when I take the square root, so this will give me plus or minus the square root of 9 over 2 over the square root of 2. So that becomes plus or minus 3 over the square root of 2. Okay, so now let's substitute this into, how about this equation here? So let's see what we get. All right, so then I have negative absolute value of x plus, so let's take 3 over the square root of 2 equals 0. So what this is going to give me then is that the absolute value of x equals 3 over the square root of 2. So there's only two solutions where this is true. Either x equals 3 over the square root of 2 or x equals negative 3 over the square root of 2. So since this is absolute value, remember you break this into cases. You have the positive and the negative case. All right, so let me clear a little space and let me just note the solutions that we have now. So we have the solutions 3 over the square root of 2, 3 over the square root of 2. And then we found the negative version of this, so negative 3 over the square root of 2 and 3 over the square root of 2. So this was all found from just plugging in y equals positive square root of 3 over 2. So now I'm going to get rid of all this, And now let's use y equals negative 3 over the square root of 2. So I have negative absolute value of x minus 3 over the square root of 2 equals 0. So then that's going to give me negative absolute value of x equals positive square root of 3 over, square root of 3 over 2. And then if I divide by negative 1, I get absolute value of x equals negative 3 over the square root of 2. And okay, so now I just have to rely on the fact that I know absolute value can't equal a negative number. So this has no solutions. So we're done. We found all of the possible solutions in this case, and so this would be it. Okay, so now with these last two problems, I've shown you a variety of techniques at this point, and so now I kind of want to give you a moment to try some of this on your own. So here is a problem. I will tell you that I think elimination is better, but you are going to have to manipulate this problem a little bit before you can use elimination. I highly recommend that you try this one totally on your own and then hit play when you're ready just to see how you're understanding things. Okay, so like I said, this problem, I want to use elimination. Now, I cannot eliminate in its current form, so what I'm going to do is I'm going to multiply, let's multiply this times negative 5. So I have negative 15x squared minus 5y squared equals negative 15, and then 4x squared plus 5y squared equals 26. So if I combine those two equations, then I get negative 11x squared is going to equal 11, which is cool because then if I divide both sides by negative 11, I have x squared equals negative 1. And so then if I take the square root of that, I have plus or minus the square root of negative 1, which means that my x is equal to plus or minus I. Okay, cool. So now I need to substitute this back into one of these two equations. So let's take positive I. So I have 3i squared plus y squared equals 3. So what's that going to become? That becomes negative 3 because I squared equals negative 1. So negative 3 plus y squared equals 3. So if I add 3 to both sides, I have y squared will equal 6. So y is going to equal plus or minus the square root of 6. So I actually have a handful of solutions now, so let me clear some space. Okay, so the first set of solutions I have is I square root of 6 and I negative square root of 6, okay? So now, what about if I do negative I? So let me clear a little space. So now if I plug in negative I, well, this actually is just going to be the same thing. So I'm still just going to be left with, so if you were confused about the calculation here, so just to show you how that works. So this would technically be, let's see, let me put it over here. I'll just write it over here in case you want to see those details. I know the i's kind of mess with people's heads. So if I have negative I squared, so you can think of that as negative 1 times I squared. So that's negative 1 squared times I squared. So that's still just going to be negative 1 because negative 1 squared is just going to be 1. I squared is negative 1, so this just equals negative 1. So it's actually the same thing as before. So this becomes negative 3 plus y squared equals 3. So I still have y squared equals 6. So it's the same thing. So I have negative I square root of 6 and then negative I negative square root of 6. So those would be all my solutions. Okay, and so I think this video has already gotten long enough, so I think I'm going to cut it off there. So I will catch you guys in another video. Thanks for watching.